Alright guys, as you're getting out everything, please get out your journal, calculator, and pencil pouch. I want you to solve the inequality 4 parentheses k minus 5 plus 12k is greater than or equal to negative 4. As you're solving this inequality in your journal, your test from last Thursday will be passed out to you, and then you guys will go over the answers with Miss Osborne and then look at some commonly missed problems. So after you're finished with going over the test answers, then we'll start going over the warm-up. So Miss Osborne will pause this. As you're working on the warm-up, she will hand out the test. Okay, so let's go ahead and solve this inequality. This is from Unit 1, just to recap and spiral back what we've learned. So I'm going to solve this just like any other type of multi-step equation. The first thing that I'm going to do is get rid of those parentheses. So I'm going to distribute that 4 to the k and the negative 5. So 4 times k is 4k. 4 times negative 5 is negative 20. I'm just going to bring down that 12k and bring down that greater than or equal to negative 4 on the other side. Next step I'm going to do is look and see what I can combine that are like terms on the left and the right side. So it looks like I can combine the k's. So 4k plus 12k is 16k minus 20 is greater than or equal to 4. And again, I'm solving for k here, so I'm going to add 20 to get rid of that negative 20 on the left side. Add 20 on the right. I now have 16k is greater than or equal to 16. Then to get k by itself, I have to divide by the coefficient. Now remember our little rule with the inequalities. If this was a negative number, I'd have to flip the sign, but since it's positive, I leave the sign the same. So my answer here is k is greater than or equal to 16 divided by 16 is 1. So possible solutions could be 1, it could be 2, it could be 3, it could be 4, it could be 5, because those numbers are all greater than or equal to 1. Okay, so that goes over just what we've learned so far. Today we're going to move on to the next unit. We started talking about continuous and discrete graphs on Friday. Today we're going to talk about functions. So on the next page of your journal, go ahead and head that relations and functions. Today is September 19th, 2016. And don't forget to go back in your table of contents. This is my page 35. So I'm going to go ahead and label that 35 in the table of contents. I'll give you a second to get that ready, and then we will begin. So let's begin with the definition of a function. What a function is, and this is very important, is that a function pairs each domain, which we're going to talk about. That means it's each x value, with one range value, which is the y's. And you're going to hear me say domain and range a lot. This is just the beginning of it. We'll talk about it with linear functions. We'll talk about it with quadratic functions, exponential functions. So we have to talk more about this domain and range thing. So after you're done writing down the definition of a function, I want you to make a t-chart that has the x and the y. And what we're going to do is we're going to discuss other names that could be used for the x value and the y value. So like I just said, domains are the x values. Whenever you hear domain, okay, you need to automatically think all the x values are also called the domain values. Ranges are called the y values. Now one way that you can remember this, and you will get this pretty quickly, is one kid from my last year's class said that he remembered ranges were the y values, because usually if you live on a range, you say y'all, so that would be the y's. So that's one way he can remember it. Another word that you're going to hear for the x values is usually if you want to find the value of x, you're going to have to input something. And once you input the value of x, you're going to find the y value, which is the output. So again, domain, input, and x values are all the same. Outputs, ranges, and y values are the same. And then the last thing is the x values are independent variables, and our y values are our dependent variables. This sort of falls along with science. If I look at quadrant 1 on the graph, in science class you learn this as dry mix. Now some of these are also incorporated with math. First thing, again, is the y values. This again is the y, this is the x. So that's where the y and the x come from. Okay, the d here for the y values represents the dependent variable, and the I stands for independent variable. The R and the M, you can say that the R represents the ranges. I'm not sure what the M represents. That's something that's science related. So if you think a dry mix, that's one way of doing that. Okay, but again, x values are domain, input, and independent variables. Y values are the ranges, output, and dependent variables. So you're going to hear a lot of domain and range for right now. So let's talk about what is a function and what's not. Now again, a function pairs each domain value with one range value. So we're going to make a t-chart, and I want you to write function on the left and not a function on the right. And this is one of the easiest TEKS that you will have to know in algebra. And this was sort of introduced to you in 8th grade curriculum last year, so your 7th grade per AP class. But I want you to put a big star here, and we're going to highlight this. A function means that all the x values are different. Not a function means if 2 or more x values are the same. And we're going to highlight that. So it's a function if all the x values are different. Doesn't matter about the y values. And then if it's anything else, then it's not a function. So all the x values have to be different. So one way that they can ask this type of question on the EOC is they could give you a pair of coordinate points. So let's say we have 1, 6, 2, 5, 6, 5, and 0, 8. They give you these points and they ask, do these points represent a function? Okay, so again, a function means that all the x values have to be different. So if I'm looking at the x values, I want you to highlight the x values that are in these ordered pairs. Okay, remember the x values are always the first ones. So if I look at these x values, I have 1, 2, 6, and 0. Are all of those different? Yes, they are, so this would be considered a function. We don't care that the 5s, which are the y values, are the same because, again, that doesn't make the function or not. It's only if the x values are different. So an example of a not function, let's put 5, 6, 7, 2, 5, 8, -7, 4, and 6, 3. So again, to determine if it's a function or not, all we have to do is look for the x values. So I'm going to highlight my x values or circle them. 5, 7, 5, -7, and 6. Now what x value determines that this is not a function? What x value determines that this is not a function? You should have said 5, because 5 is repeated and we cannot have the same x value, so that makes it a not function. Now notice I have a 7 and a -7. That doesn't matter. Those are two different values. 7 is a +7. This is a -7. So that would still be considered a function. Say I take out this first point, that would be considered a function. But because I have that 5 listed twice for the x value, that makes it a non-function. Okay, so they could give you ordered pairs and have you identify if it's a function or not. They also could have you or be giving you a table. So let's make our XY chart. We'll make 2 for each. Okay, and for this XY chart, we'll put 0, 1, 2, 3, and 2, 4, 6, 8 for the first one. And then the second one, 0, 1, 2, 3, and we'll put 2, 2, 2, and 2. Now again, the main thing is to identify if this is a function or not. So I'm going to look at just the x values. So on both of these tables, I have the x values are all different, which means that would make a function. Now this second one I threw in there because this is where some people get confused, as they look at the y values, which we don't really care about the y values, but they still get that confused, and they notice they're all the same, so they consider this not a function, but that's not true. Again, we only focus on the x values. So I want you to try to think of a way that you can remember if the question asks you, is this a function? How do you remember that you just really care about those x values? So think about that. And if you think of a good way, share it out loud with the class, and hopefully that would make it easier on some people so we don't make those common errors. Let's do an example of not a function with our tables. So let's do our XY charts again. And we'll do the first one together, and I'll have you make up an XY chart that's not a function. So let's do 2, 1, 0, 1, 2. And I'll put -5, -3, -1, 0, and 4. So again, what values here, what x values make this not a function? Okay, you should have said, again, I'm looking at all the x values, and I'm looking for any duplicates. So the 2 and the 1 are actually doubled, so both of those values make this not a function because I cannot have 2 of the same number. Okay, why don't you go ahead and create your own now x and y table that represents not a function. Take a second to do that. When everyone's ready, I want you to share with your neighbor, and then look up here at mine and see if you have something similar. Okay, so my xy table that would represent not a function, I'm going to have all the same x values, so -3, -3, -3, -3, and then I'll put 2, 3, 4, and 5. So again, this is not a function because every single x value is the same. Okay, so there's two ways they could ask you so far if it's a function or not. They can list them as ordered pairs, or they can give you the table. The next thing might be new to you, and this is called a mapping diagram. You may have seen this, you may not have. We're going to do a mapping diagram example for both. And it's just another way of organizing your data from the function. What a mapping diagram is, it's two circles, So draw your two circles. The first circle represents our x values. The second circle represents our y values. So again, it's just another way of organizing, because if I think about it, okay, graphing ordered pairs, this XY table is just another way of organizing our ordered pairs. Same thing here. The mapping diagram is just another way of organizing our ordered pairs. So, I'm going to give you the mapping diagram. Let's put 6, 5, 2, and 1. It doesn't need to be in order. And then I'm going to have -4, -1, and 0. Now I just told you that the mapping diagram represents ordered pairs. Well, I have 4 x values over here and only 3 x values over here. So how do I show which ones are actually matched up together? Well, a mapping diagram uses arrows to show the ordered pairs. So if I put maybe an arrow from 6 to 0. Okay, that shows me this is 6, 0. That's in the function. Let's go 5 to -1. So again, write that ordered pair, 5, -1. Let's go 2 to -4. And we'll go 1 to 0. Okay, so this is the mapping diagram. Now, they're not going to give you the ordered pairs written out, so it's never going to look like that. It will look something like this. And what you have to remember is, even if the numbers are uneven, because again, I had 4 in the X column, 3 in the Y column, you have to remember that the number of arrows represents the number of ordered pairs, or points on the graph. Go ahead and highlight that. The number of arrows on a mapping diagram represents how many points are on the graph, or ordered pairs. So now, looking at this mapping diagram, I notice there's only one line coming from each number, so it's not doubled. And even if I look at my ordered pairs that I wrote out, 6, 5, 2, and 1, are never repeated, so that would be considered a function given in the mapping diagram form. Here's what a mapping diagram looks like that's not a function. So again, draw your two circles. They won't label the first one X's and the second one Y's. So you just have to know that the first circles are X's and the second ones are Y's. So I'm going to just give you the mapping diagram, and what I want you to do is write out the ordered pairs from the mapping diagram. So I'm going to have 7, 9, 12, and 15. Y values, I'm going to have -7, -1, and 0. And this is how I want you to draw your arrows. So from 7 to -7 is an arrow. 7 to 0 is an arrow. 9 to -1 is a 0. I'm sorry, 9 to -1 is a point. 12 to -1 is a point. And 15 to 0 is a point. So, I want you to identify every single point that is in this function by listing them out as ordered pairs, and then determine if it's a function or not. Whenever it's done, then Miss Osborne will push play. Okay, so I notice, first off, the number of arrows represents the number of ordered pairs. I have 1, 2, 3, 4, 5 arrows, which means I need to have 5 ordered pairs. So if I look at this first point, 7, -7 go together. X is a 7, Y is the -7. The next point is 7 goes to 0. That's another arrow. Then I have 9 to -1. 12 to -1, and the last one is 15 to 0. So if I have to identify if this is a function or not, again, I'm just looking at the X values, and I notice that the one that is doubled or duplicated would be the x value of 7, because again, if I look at my graph, there's 2 arrows coming from that 7, so I know that that is not a function. Okay, so again, usually on the EOC they ask you the question, which one does not represent a function? And your answer choices, 4 answer choices, one will be a ordered pair, one will be a table, one will be a mapping diagram, and then the other one will be a graph. So we're going to look at the graphs and how to determine if it's a function or not from a graph. So continue your T-chart, function or not a function. And one easy way of figuring out if it's a function or not from a graph is called the vertical line test. And it sounds exactly like what it is. Okay, what the vertical line test does, it's a vertical line. Again, vertical means up and down. Think of if you're in athletics and they test your vertical, you're jumping up and down to see how high you can jump. So it's a vertical line that passes through points on a graph. And if that vertical line hits it one time, that means it's a function, and we're going to show you some examples in a second. And if that vertical line hits more than one time, it is not a function. So that's huge to remember. So let's look at some graphs. Let's go ahead and draw. We'll draw 2 graphs for each one. So draw your 2 graphs, all 4 quadrants. And let's just pick random points. So I'm going to pick this point, this point, this point, this one, and this one. Now sometimes they'll just be points, or sometimes they'll actually be connected. So we'll actually connect these points as well. I'm going to do it in different colors so you can tell the difference between my x and y axis and my function. Okay, so vertical line test. That means each of those points I draw a vertical line through it. Easy enough, right? I'm drawing a line, a vertical line through this point, through this point, through this point, this point, and this point. There's my vertical line. Now, if the vertical line only hits that function one time and it never hits it again, that means it's a function. And it has to work for every single point that's on my orange line. Okay, again, this one hits it one time, hits it one time, hits it one time, hits it one time, which means this is considered a function. Okay, now what kind of function is that? If it makes a straight line, this is our linear function. And we're going to look into that very shortly. Now let's do another one. This is another type of function that you're going to be learning later on. Draw some points like that and connect them to make a U shape. Notice that my functions have arrows on the end because it's continuous. It keeps going and going. Now again, I draw a vertical line. So here's one line, there's another one, another one, another one, and another one. And for this quadratic, this is called a quadratic, which we'll learn around spring break time. is that it keeps getting wider and wider every time, so that's why it will never hit. So again, each vertical line only touches it one time, so that would be considered a function. Now, what do non-functions look like? Okay, let's just put a point here, a point here, a point here, and a point here. Sort of makes like a Z. So if I actually make a Z out of this, that might be easier if you draw a Z first and then connect the points, or find points. Again, this is a function, a type of function. I'm going to go ahead and draw a vertical line through each of those points. So here's one, here's another one, and here's another one. And if I add another point right here, okay, let's take a look at these vertical lines. This vertical line has it touching the function 2 times. That automatically tells you right there it's not a function. Even though this last point only hits it once, that does not matter, because at any point where I draw a vertical line and it hits it 2 times, this one hits it 1, 2, and 3 times, as does this line. It hits that function 3 times. So that would be considered a non-function. Okay, sometimes you'll just be given points, so something like this. Random points, and they'll ask you if that's a function or not. Again, all you have to do is draw a vertical line through each of those points. And right then and there, these points and these points share the same x values because they're stacked up on top of each other. So that would be considered a non-function. You also could see a graph that looks like a sideways U shape. And again, to determine if it's a function or not, all you have to do is draw vertical lines. And every vertical line I hits it twice, except maybe this last one hits it 1 time, but it still is not a function because there's at least one vertical line that hits it more than 1 time. So we have to remember, if the vertical line hits it just 1 time, it's a function. If it hits it more than 1 time, it's not a function. And we're going to practice this more with a game coming up, so I will explain that to you shortly.